Hello. In this video, we're going to go ahead and solve some more trig equations. But to start off, let's just have something simple. Sine theta equals -1/2. Let's solve it in radians and find the exact value. Well, we can go ahead and use our regular method, sine inverse of 1/2. Make sure our calculator's in radians and we drop the negative. If you have the Mr. Peters approved calculator, this will give you pi/6, which is kind of nice. It's a unit circle value. And if we use the cast rule, we're looking for a negative value for sine. So we're thinking that's going to be down here and here. That means our angles are going to be 180, which is pi, plus pi/6. So 7 pi/6. And then 2 pi minus pi/6. So that's going to be 11 pi/6. Now, you would be able to come up with this as well if you just use the unit circle, but it's nice to use your calculator just to combine the methods. Again, if you don't have the Mr. Peters approved calculator, you kind of have to do it with the unit circle because the values you would get here, when you do sine inverse of 1/2, you'll just get 0.523, some random decimal stuff, which won't actually give you an exact value. So I would recommend you get the Mr. Peters approved calculator for this question. But moving on, what I would like us to do is solve something a little different. We'll go back to algebra land for a minute, and I'm going to give you -5 minus 4x equals 4x squared minus 4. So just pause the video and see if you can solve this algebraic equation. All right, hopefully you're able to figure it out. You kick everything to one side because it's a square, so you have 4x squared plus 4x minus 1. Oh, sorry, plus 1. Then we're going to go ahead and factor that. So we'll get 2x plus 1, 2x plus 1. And so that means x equals -1/2, and x also equals -1/2. Again, if you were struggling a little bit with that in-between factoring step, right, what we do is we take that middle term, we break it out as 2x plus 2x plus 1. We get a 2x in common here, giving us 2x plus 1. We have nothing in common, so we put a placeholder 1. Then we factor out the 2x plus 1. And we're left with another 2x plus 1. So this is called group factoring. If it's a little bit foggy, go ahead and Google it, watch a quick video, and you should be good to go. All right, so why did we take a little trip down memory lane? Well, let's say we had a situation like this, where we have a trig equation, but it looks a lot harder than before, and in particular, we have a squared here. We have sine squared. That's not going to be solvable with our regular method of isolating the trig ratio because, well, I mean, if we moved everything over, right, if we move the 5 over here and move the 4 sine over here, we're going to have something like this. We're going to have 0 equals 4 sine squared theta plus 4 sine theta plus 1. And how are we supposed to get sine by itself? It's got a sine squared and a sine. This just doesn't really work. So we need to kind of solve this equation, and hopefully you see a connection here. This equation looks a lot like this equation. We have a 4x squared plus 4x plus 1. We have a 4 sine squared theta plus 4 sine theta plus 1. You should see a little connection here. It's almost like instead of having an x, we have a sine. So it's like a sine squared instead of an x squared. It's maybe I'll do that with a highlighter here. Right? The x and the x kind of take the place of the sine and the sine. And so this almost looks like the exact same equation, and indeed we can use the same principles as before. We would go ahead and set this up with group factoring. So 4 sine squared theta plus 2 sine theta plus 2 sine theta plus 1 equals 0. Then we would go ahead and factor out the 2 sine theta in common with those first two terms, leaving you with 2 sine theta plus 1, because sine theta times sine theta is sine squared theta. Here we have a placeholder 1, 2 sine theta plus 1. Then there's a 2 sine theta in common, 2 sine theta plus 1 in common, I should say. Factor that out, leaving you with 2 sine theta plus 1. From here, we set each one of these little factors equal to 0. So you get 2 sine theta plus 1 equals 0 and 2 sine theta plus 1 equals 0. They're both actually the same as this. So I'll just go ahead and do the one of them. We don't have to do both. So we kick the 1 to the other side. And then we divide by 2. And we get sine theta equals negative 1/2, which is actually that very first question we started with. And we know this is true. The solutions are theta equal to 7 pi over 6 and 11 pi over 6. And so what we have here is kind of a combo question, right? If you look at this last step here, okay, this was the first question we did, and this was what we've done in the previous lessons. This is kind of like a trig equation. In fact, even starting as recently as here, this stuff right here, this is all prior knowledge. We've already done this. These are trig equations. We take a trig equation, we isolate for the trig ratio, and we solve it. We use the cast rule or a calculator, unit circle, etc., etc. That's all stuff that we've covered. And if you look up here, all of this stuff, well, all of these things are basically just algebra. It's just algebra where instead of having an x, you have a sign. So what we're doing now is we're combining these two skills. We're combining the skills of algebra and factoring. So this algebra, or if you want, you can think of this as factoring. So we're doing algebra and factoring, and then we're doing a trig equation. And we're doing both in the same question for added fun. So here we have 2 tan squared theta equals 2 tan theta minus 1 plus tan squared theta. We want to solve in radians and get the exact value. So I'd encourage you to pause the video and at least give the algebra a try. See if you can get all the terms to one side and maybe even factored. All right, assuming you gave it a try, we can subtract 2 tan theta, add 1, subtract tan squared theta. So that's going to give us, well, the 2 tan theta doesn't line up with anything, the 1 doesn't line up with anything, but the tan squared does. So that'll just give us 1 tan squared minus 2 tan theta plus 1 equals 0. Then we need to factor it, and this looks not too bad. Tan theta minus 1 times tan theta minus 1 equals 0. We're looking for two numbers that multiply to give 1 and add to give minus 2. So I think, yeah, those numbers of minus 1 should work good. Now this tells me that tan theta equals 1 and tan theta equals 1. I'm going to go ahead and skip this because this is the same as the one on the left. So how do I find tan theta equal to 1? Use our unit circle. It's going to be here and here. We could use a calculator, but these ones we should know. Theta equals pi over 4 and 5 pi over 4. And we're good. So let's go ahead and try another one. We have 2 sine squared theta equals 1 minus sine theta. Again, go ahead and pause the video and give it a try. All right, well, we can take the 2 sine squared theta plus sine theta minus 1 equals 0. Move everything to the left side. And maybe you're just not comfortable using sine thetas. Maybe you don't like moving it around like this. One thing I'll show you, just as another method, is you can let sine theta equal something. You could say let it equal x or y. You could let it equal an actual letter. So in this case, let's let sine theta equal x. So rather than moving it around, if you don't like that, we would have 2x squared equals 1 minus x. Now we'll move it around as 2x squared plus x minus 1 equals 0. We're looking for two numbers that multiply to give -2, add to give 1, so 2 and -1. So we'll get 2x squared plus 2x minus 1 equals 0. 2x in common, x plus 1, minus x plus 1. So x plus 1, 2x minus 1 equals 0. That means x equals -1 and x equals 1/2. Now the only downside to this approach is you might be tempted to just box your answer and walk away, but this isn't the end. All we've done here is we've done the algebra in terms of x's instead of sine thetas, because maybe it's a little more comfortable for you. And again, you're more than welcome to do that if you feel so inclined. But just to show you, we do need to finish off the question. So here we now need to write sine theta equals -1 and sine theta equals 1/2, because that's what x was. X was just temporarily the sine theta. We're actually solving for theta, so we do need to finish off the question. But where is sine theta equal to -1? Again, use your unit circle. That's going to be at theta equals 3 pi over 2. Where is sine theta equal to 1? That's going to be at, let's use the cast rule here. Boom, boom. Pi over 6, 5 pi over 6. And so these are your three answers, and we're good to go. If you prefer this method instead of using the actual trig functions in the algebra, you're more than welcome. The only thing you have to make sure is that you make a statement like this. You can't just start introducing random variables. You have to say that x is your new variable, and then of course you have to make sure in the end that you solve for theta. All right, let's try another one. We have secant squared theta plus secant theta minus 2 equals 0. So go ahead and pause the video and give it a try. All right, again, I'll show you that little method. You could let x equal secant theta. So this is x squared plus x minus 2 equals 0. So looking for two numbers that multiply to give -2, add to give 1, x plus 2, x minus 1. So x equals -2, x equals +1. Now we have to switch back to our secant. So secant theta equals -2, secant theta equals 1. Now to be honest, secant's a bit of an oddball. We're used to dealing with sine or cos. So what I'll usually do now is I will convert, because I don't actually know the secant unit circle and I don't have a secant button on my calculator. So it's better to take these values, and instead of writing secant theta, we can write this as 1 over cos, because that's what secant is. So instead of saying secant theta equals 1, it's like saying 1 over cos equals 1. And then we do the reciprocal to both sides, because instead of having 1 over cos, we'll just have cos. Instead of having -2, we'll have 1 over -2. Over here, the reciprocal of 1 is just 1, so that's easy enough. And again, we want to utilize that unit circle. So where is cos theta equal to 1? That would be at 0. Where is cos theta equal to -1/2? That would be 2 pi over 3 and 4 pi over 3. Now these questions may or may not be in the calculator section, but again, because these are pretty exact values and they're from the unit circle, I would want you to be able to do at least these questions without a calculator. There might be some that you would need a calculator for, and we can look at those maybe in another lesson. But at least when they're coming out with like 1/2, √3 over 2, 1, 0, those nice numbers, you should definitely know those from the unit circle. Now we'll go ahead and take some notes on this. So we could call this solving trig equations of degree 2 or more. So this is where you have something like sine squared theta minus 1 equals 0. The problem here, of course, is the degree 2. because of this, we can't usually isolate. Instead, we have to use factoring. And sometimes it's nice to do something like let x equals sine theta, because it makes your algebra a little bit more, not easier because it's the same algebra, but just more intuitive. You're more used to factoring polynomials with x's than you are factoring polynomials with sine thetas in them. And again, after that, after you're done the algebra, after algebra, it's the same as before. Same steps as before. So for your example, why don't you go ahead and solve that equation? Sine squared theta minus 1 equals 0. Just to give you a hint, this is a difference of squares, so the factoring should be pretty easy for you. Go ahead and give that a try. All right, hopefully you tried to factor this. You should have sine theta minus 1 equals 0. Or sorry, I'll factor both. Sine theta minus 1 and sine theta plus 1. So that gives you sine theta equals 1, sine theta equals negative 1. That's going to be pi over 2. That's going to be 3 pi over 2. And those are the two solutions. Again, down here, you can choose an example. This is Unit 6, Worksheet 6. And then any things to remember. All right, hopefully you enjoyed this video. And as always, thanks for watching.